So our next presentation is going to be from Manuel Menchaca from SatLink, and he's going to be giving a presentation on enhancing sustainable fishing with electronic monitoring, one step closer to real-time automatic capture detection. So welcome, Manuel.
Well, hello everyone. I'm very happy to be here. Thanks to the SAFET organization and also public administration for this fantastic event with great speakers and great topics. Well, I'm Manuel Menchaca. I'm an electronic monitoring consultant. Today, I'm going to present SatLink machine learning models that currently we are using with the industry. And also, I'm going to show you some real examples about how it works. And I'm also going to open a debate about where we can use these machine learning models, with the onboard equipment, on cloud, or at the edge. So let me start. Let me start with an introduction of my company. SatLink, as you may know, is a technology company that develops solutions for the fishing sector. We have a disruptive DNA. That means that we create new technology. We have a global presence. As you can see in the map, we have several regional offices. We also have an international reliable partners around the world to provide service. And we believe that the technology is a big driver to change the things. So the most part of our solutions are focused on better management of the ocean resources and, of course, fleets. We also believe that technology is something that you have to do in hand with the industry, the retailers, the NGOs, and of course the most important part of the chain, which are the fishermen. Also, SatLink is a company with international expertise in the project deployment. As you can see in this map, we have several projects around the world. We don't have fear to trip. We are in the Pacific, but also in Africa, Europe, North and South America. So let's move to the interesting part of this presentation. EM. Well, I suppose that everyone knows what is EM. In my opinion, EM data is something that is crucial for the ocean sustainability. If you have good data, you are able to make good decisions. EM is a system, an onboard equipment, which is based on cameras, on sensors, BMS, and GPS. And thanks to this, we are able to capture verified data, which is catch, bycatch, discards, transshipments, waste, fishing efforts, and of course, labor rights. So thanks to this information, we are able to make traceability, a better or efficient management of the resources, and the outcomes are very clear with EM. The protect of the ocean resources, and of course, the sustainable fishing. So the debate that I want to open today is that machine learning models and algorithms are a very powerful tool that can help us with the video review. And there is something interesting that is where we apply the machine learning. So there are three approaches or three models or scenarios that are the following. The first one is the onshore computing. This model means that at the end of the fishing trip, for example, with the offshore fleet 6 or 9 months, you have to collect the disk and send to the review center when you can use the machine learning models to analyze the footage. This first approach has a problem, which is the long time to get the results. The second option is what we call near real-time computing. In this case, you don't need to collect the disk and ship into the review center. In this case, using any cellular connectivity or satellite, you are able to transfer the information directly to the cloud, and then in the cloud, you can apply the different machine learning models. In this case, you also have drawbacks. The most important is that sometimes the coverage is not good, or probably you have problems with the speed data transfer, but it works very well. And finally, we have the third scenario, which is the onboard real-time edge computing. In this case, you don't need to transfer information or shipping any disk to the review center. In this case, using the onboard equipment, you are able to use your machine learning models to process the information. Here, the big issue is that you don't have the same power machines that you can have onshore or on cloud. and you run small models, so you probably get worse results. So there is three scenarios, and let me say that depending on your needs, you can apply one of them. So I mentioned at the beginning of the presentation that SATLink has currently different machine learning models that we are using with the fishing industry. The models that we have available today are long-line assisted detection that can be run on shore and, of course, near real time. With this model, we are able to detect and classify individuals, fish, and others using the footage collected by the EM system. Indeed, we are also making some progress in these models, and we have included a tracking algorithm in order to reduce the number of duplicates that you get when you use this model. We also have for the long line setting and holding detection. This model can be run in the free models, in the free approaches, onshore, near real time, and edge computing. With this model, we are able to detect the setting and holding operations. Then we have the percent braille detection, very easy. Thanks to this model, you are able to detect the start and the end of any braille operation, and that's very helpful. And finally, we have the privacy guarantee. That is a model that nowadays we are using in the edge. That means that we are able to blur the faces or the bodies of the fisherman. So this sensitive information, which is identity, remains in the vessel. So let's move to the first model, the detector and capture. We have years of investment tagging with our biologists the different images to have a huge database of around 300,000 images. We have over 9 years of proprietary data with our EM systems. And we use cutting-edge deep neural networks for this image detection. So as you can see with the catch, the level of detection is 99%. It's incredible results for tuna. And with the bycatch, we have worst results. And let me say that is because it's very difficult to find good images about the bycatch. Very, very difficult. I know the people who is in the sector knows that it's very difficult to have sometimes the bycatch on deck, so it's not easy to classify those images. So let me show you an example, if I can. Okay, so if I click here, I don't know, this is a video, but, okay. Pam, pam, pam. Okay, thank you very much. So this is an example, a real example of the detection. As you can see, you have the box square with the detection, and then you have the classification of these species. And this is something that we are using nowadays with the industry. And it works very well because it helps a lot the analyst because you have a pre-classification of the species. So it's very easy to go to the precise moment and say yes or no. This is a big eye or this is another species. This is the setting and holding detector. So basically, based on GPS information, speed, course, and dates, we are able to know if we are with the setting and the holding operation in long liners. Here we have another video. This is the braille detector. Very easy. We are able to know the start and the end of the braille operation. So it's very easy to go to the specific moments when you are reviewing the data. Yes, it's a lot of tuna. Yeah. Okay. This is another video. This is how it works, the privacy mask. This algorithm is run using the cameras. So basically the idea is that it's not possible to identify the fisherman, so the identity remains in the vessel. As you know, with electronic monitoring, one of the big concerns is the identity of the fisherman. We don't like cameras. I know, I work with cameras. So we are using this kind of technologies to break this wall, which is the identity of the people. So let me say some edge computing challenges. The first one is the power consumption. You need powerful machines in order to apply these models on the edge. Then there is also an issue with the space on board. Sometimes it's not possible because you are within small vessels. The environmental limits, the cooling, and also the humidity. Then the maintenance. Sometimes it's not possible to connect remotely to the computer, so it's very difficult to make any update or any maintenance with the models and the equipment. Also the accuracy and the model limitation. I mentioned before that I'm trying to do with the capture detector, but the results are not very good because you are running a small model. And finally, an idea which is the mixed computing. Why we don't combine the different approaches to get results. And to finish, I don't have much time. We are presenting a new product in SATLink, which is called SATLink.ai. Basically, it's a cloud-based service that allows to use the SATLink machine learning models that today I'm presenting. And the idea is that you can integrate in any review software using an API. So it's a different approach. It's the option of use our technology with your review software. So that's all. Thank you very much.